I'm Sergiy Tikhonov, and I am in charge of XR development, engineering at software development company Sergiy. Sergiy is one of the biggest Ukrainian IT company and the number one through the Ukrainian XR developers. It's why for us in Sergiy, industrial implementation of XR technology is the most crucial focus of our development, and we are effectively solving today's challenges using virtual, augmented, and mixed reality and computer vision. Therefore, today I want to speak about our experience and our XR cases in the manufacturing, and hope it will be a good starting point for our further discussion. So let me start with a short presentation of our cases, and then we will have a Q&A session for the discussion. Today, I highlight the delivery of the digital twins on the augmented reality, mixed reality technology, computer vision implementation for manufacturing. In the most typical cases, we are considering digital twin as a 100% accurate 3D replica of the piece of equipment created based on CAD or CAM documents and drawings. So the majority of users still regard digital twin as a marketing solution mostly. It's much more than that. Digital twin help the product visualization and promotion. They can also be used for training of employees. Digital twin can be demonstrated with the help of most popular technological devices, like tablet, last iPad Pro is fantastic for this purpose, and smartphone for sure. On the other hand, they can be viewed via Microsoft HoloLens, top-notch mixed reality devices for visualization. Digital twin are interactive. User can investigate a piece of equipment from the whole size, disassembly or assembly this equipment, move some parts of this device. He or she can listen to the equipment working. The photorealism of equipment, the ability to see it at full size, contribute to the realistic perception of full immersion for potential client in the process of exploration. Manufacturing is most profitable field for application of computer vision. Even a small pause in the production costs a lot of money for the company. Computer vision technology can detect future damage or possible risk in advance by collecting images and analyzing them in the cloud. Moreover, computer vision and artificial intelligence can be used to improve health and safety of workers in the manufacturing facilities. By the aid of the large number of real-time cameras, the computer vision technology is possible to track movement of people and rely on deep learning to predict and avoid dangerous situations for workers. While manufacturing is a historically slow-moving and conservative industry, COVID-19 has created challenges that requiring manufacturers to innovate at speed as we have never before. Business trip and the opportunity to meet 1,000 of potential customers on a trade show are in the past, which dramatically shrink sales pipeline. But if you deal with large, heavy, and sophisticated machine, you clearly understand how direct sales are significant, and XR Tech gives us hope. Widespread globalization means nearly every supply chain is impacted by COVID virus region, open, close, potential multiple time over the next couple of years, and manufacturing are going to struggle with companies shortage. Small companies and specified production are most unsafe. They often have single-sourced component they rely on. Mitigation the shortage and taking uncertainty out of equation means building new digital relationship with partners and production. Factory and the suppliers are often thousands of kilometers away from where electronic products are designed, making traveling essential part of development and production, especially if we talk about new products. Building and maintenance the relationship with suppliers, solving complex engineering problem, and understanding the physical challenges of why something is difficult to assemble, and rely on personal interaction with people and prototype hardware. Restricted movement of people around the globe is expected at least for a couple of years, required a new way of the development, new product remotely. Old-fashioned but effective offline training for workers unavailable too. But online education still has many issues, especially if you talk about complex industrial equipment and processes. So problems raised by COVID-19 is not go away overnight. We will see the fast adoption of innovative technology at scale, because there are no other choice. For example, Forbes estimates the 5 years innovation happen in the next 18 months. So digital twin is the idea of bridging physical and virtual world when data transmitted seamlessly through the IT platform, allowing the virtual entry exist simultaneously with physical entry. Digital twin helps companies improve customer experience by better understanding customer needs, develop enhancing or existing products, operation, services, etc. Creating digital twin of the equipment has several advantages. First is easy to build a mixed reality application for visualization of machine that then to transport new model to the exhibition, for example. Second, it's possible to create a scalable 3D model machinery which will be fully interactive, and the user will be able to look inside this equipment, check it how it works, choose the most comfortable size to explore the model. Using digital twin, it's easy to accumulate most important and relevant data, like historical data, different KPIs, making prediction on this basis useful for the design and production. Data accumulated during the digital twin usage gives insight of fixing problem during maintenance, reduce maintenance time. Performance of equipment can be predicted and on the basis of historical data collected during the machine utilization. Combined with business intelligence, this information can be crucial for risk and performance prediction. In SoftEng, we are building a digital twin not only for physical equipment. The process are wide area for it too. For example, digital twin of complex supply chain effectively simulate the logistic network and optimize the supply chain in multi-dimensional space of uncertainties. Here we have a combination of the data lake and digital twin approaches. The near real-time streaming data processing enables new opportunities for real-time analysis of the logistic and manufacturing process. As a result, digital twin generate real-time alerts, instruction about prescription or prediction of how to avoid particular risk and optimize logistic network. So let me dive into one of our substantial cases, deep drilling machine, digital twin. This digital twin were developed with our German partner Staff I company for German-based industry machine producer. The primary goal of the application was create a user experience which helps sell a new model of this deep drilling machine. A couple of words about this machine. It's a big one, room-sized, has 4-meter width, 3-meter deep, and 3-meter high. It's extremely heavy, and for customer it make real problem to transport it on fairs or exhibition. For the first week of our project, we have developed fully interactive model of this machine based on CAD drawings from Microsoft HoloLens headset. For the next week of the project, we added a training feature and customized the application for Android and iOS platform. The cross-platform development based on Unity 3D ensure rapid development and high quality of this application. But let me demonstrate this experience. It's much better than 1,000 words. So here you could see captured mixed reality video from Microsoft HoloLens. As I mentioned before, we created application using Unity 3D platform. It's really perfect tool to create this kind of application, especially cross-platform application. At the very beginning, the headset scans 3D model and of the real environment and finds the plane surface to place 3D model. User interact with application by gestures only, but we implemented voice control nearest time to as far as the real size of model big enough, user can easily resize model. The same action implemented for moving and rotation. Right now, you could see the rotation features. The digital twin is fully interactive, so that the user can run machine, run platform of the blank and open the both doors of the machine. And now you could see the side door. The next, maybe most significant usage of the twin is the training mode. And to make this training more effective, we are made unnecessary element invisible to focus user attention on the essential part of the machine. This 3D model consists of 10,000 details and parts, so technicians can quickly investigate each nut or bolt of the machine. Sergiy has developed the training mode for operation of drilling tool replacement. In this mode, user can see the text of the step-by-step instruction, and then application demonstrate animated and interactive operation with gestures and usage of tool or details of particular specific part. Here right now you can see how user unlock chain, unfold bracings, and use the tools. So anytime user can return to text instruction to clarify some point. The same user experience we implemented for Android and iOS smartphones and tablets. This makes the application simple to roll out onto different user groups and potential customers. This case is crucial for us as we have got the idea how to enhance the digital twin with distance consulting and can come up to remote assistant platform. Our customers usually need direct consultation and guidance with the technical the shop floor to support the maintenance, diagnostic, or repairment operation. Therefore, we build the video streaming platform with augmented reality technology to support rapid development of this kind of application. For audio and video streaming, we are using WebRTC. It's a well-known open source project which allow direct peer-to-peer communication. The remote assistant application allow not only interact with 3D model, but share your augmented experience with remote participant. In this kind of remote collaboration is critical is annotation tool. The annotation tool helps participant mark the part of real or virtual object by augmented reality markers and leave text or voice notes guarding the marked object. User can choose the shape, arrow, sphere, color of the annotation, and platform storing the position of this annotation in the space for later usage. This feature makes excellent opportunities for maintenance. It looks like breadcrumbs, which allow to create work orders for service, or field engineer can quickly locate a place of work and see all relevant information just in real time. For sure, not only service or maintenance requires this kind of interaction, this kind of experience, but this solution has a significant impact on the sales process too. So we successfully use this platform for remote sales. So let me take our example. It's a augmented reality sales tool for furniture producers, our Presentinar product. Product catalog are quite old-fashioned and limited in their reach and conversion. A large experts postponed at least 1 year, and in general, in COVID world, people hard to get to the showroom or to the shops. So we are creating this remote sales tools for furniture producers. Sales our toolkit gives the customer a feel the quality of different products. It helps buyer to see how an item fits into a room. Presentinar allow users select and evaluate item using dimensional tool and check size and configure a product with the fits they need. Augmented reality puts virtual 3D animated object in the environment for creating more personalized shopping experience for consumer. For other side, a salesperson can see real customers' environment and consult regarding product design and proper product selection, including options like a color, like a size. This kind of interaction with customers significantly increase the sales conversion. Our customer report more than 40 percentage conversion increase for particular product group and in comparison with traditional e-commerce site. The second huge challenge is lack of 3D model of the furniture. Our supervised machine learning algorithm creates 3D model of product based on pictures. It is enhanced photogrammetry approach tailored to the interior design. And last but not least, mixed reality headset create new opportunity for design. And besides, with the deep immersion, it gives the highest accuracy of positioning. In conclusion, let me move to the computer vision cases. Here we several opportunities, most of popular are listed here. Monitoring of the usage of the personal protective equipment looks like most obvious in the COVID time, mean the implementation of the computer vision for continuously monitoring of the usage by workers of the mask, helmets, gloves, vest, and in particular certain zones on the factory. The second case regarding the risk monitoring on the shop floor is collision avoidance and analysis of trajectories of multiple moving machine objects in dynamic scene to define deterministic collision courses, including monitoring the worker's position to stay clear from heavy equipment moving zone in factories. CV easily detect different industrial anomalies like detection of improper storage of material in warehouse, like edges of the box protruding out the shelf in a safe way, detection of leak, fire, smoke, gas, etc. Last time become important the solution for the production remote audit. When we use computer vision for the workers' motion detection, for example, on assembly line, and create an audit database for future workspace and ergonomic optimization. So let's take a look at the general approach of the building the risk prevention cases. Here we are using all possible sources of video streaming from the factories facilities, including the fixed cameras, smartphone or tablet cams, depending on nature of this case. WebRTC is still an excellent approach to get all this video stream on the server side for the future object and anomaly detection. Can you hear me? I hope so. So let me return to the computer vision. From the computer vision side, we use different methods like region-based convolutional neural networks for the object recognition. The final goal of the system is creating an alerts prediction or prescription for the. By the way, I'm not sure. Can you see my screen? Mm-hmm. Something goes wrong. Well, can you see my screen, the presentation? Hola.
Купил, работает. Установил, что ковырялся. Ай.
let me maybe start over the slide. Let's take a look at the general approach for the risk prevention cases. Here we are using possible sources, all possible sources of video streaming from the factory facilities, including the fixed cameras, smartphones, tablet cams, depending on the nature of the case. WebRTC is still excellent approach to get all this video stream on server side for the further object and anomaly detection. From the computer vision side, we use different methods like based convolutional neural networks for object recognition. The final goal of the system is creating alerts, prediction or prescription for the management. To do this, we establish risk identification supervised machine learning algorithm. This kind of AI solution often become a part of complex system, which includes IoT components, business intelligence, and subsystem, and for sure data warehouse. Augmented reality technology moves the business analysis to the next level of and allow build and interactive 3D data visualization on scale. I believe the creation of user interface enhanced by augmented reality tech allowed to create a virtual command center in Office. Second. So this is it. What I want to speak about today. So I'm happy to answer all your questions. Feel free to send me comments and feedbacks by email. Your feedback help us to choose most exciting of our cases for the following webinars. Thank you very much. Have a nice day.